The next form that we're going to be looking at is called standard form. And this is a form that you're used to working with the quadratic formula. You have some experience factoring ones like this and solving for it. And now we're going to look at how you can get some important information for graphing out of the formula. There's one formula you really just have to memorize, and that's in order to get the vertex. And so in order to get the vertex, we're going to use this formula, x equals negative b over 2a. And that's something that you really just have to memorize. That's how we're going to get the x-coordinate of the vertex from a standard form equation. So in this case, we have our ax squared plus bx plus c. You just want to be mindful of your signs. Now, I've written this in the proper standard form. You should do that too. And so my negative b, just be careful, in this case that's going to be positive 8. All over 2a. So when I evaluate this, I get 8 over 4, or 2. Now, a vertex has an x and y coordinate, so we're not quite finished yet. Now, basically the y coordinate, I'm going to find the y value in the function when x is 2. So this is just plugging in. And then evaluating. 2 squared 4 times 2, 8, minus 16 plus 6. It's going to be negative 2. Now from here, I've got my x and my y coordinate. I just need to go ahead and write it as a coordinate pair. And 2 and negative 2. Now the axis of symmetry is, again, very easy once you have the vertex. It's just going to be x equals 2, which is the x-coordinate for the vertex. Right, and next we're going to look at how we're going to find the x-intercepts and the y-intercepts. We're going to continue now to find the x-intercept of our standard form graph. We already found the vertex and the axis of symmetry. X-intercept and y-intercept, we're going to follow the same pattern that whenever you want the x-intercept, that's where y is 0. And if you want the y-intercept, that's where x is 0. That's where the graph is going to cross those axes. The nice thing about this is that you've already learned all the material, be it by factoring or using the quadratic formula, to be able to solve for the x-intercept. So for here, we're going to plug in 0 for y, and then move from here. And it's up to you the best way to solve this. You can either factor it, you can use the quadratic formula, or something that you'll soon be learning, you can use the square root method or completing the square. It's really up to you. I think the best thing to check first is, can we factor this? Now, when I look at this, the first thing I see is that I've got a common factor of 2 that I can divide out from all of these. And I'm going to look and see, is there any way that I can factor this? Factoring is, in my opinion, is the best way to start. Make sure you're not doing some tedious work with the quadratic formula. And in this case, I can. Two numbers that multiply to get 3 that add to get negative 4 are x going to be minus 3 and x minus 1. And then from here I'm going to solve. And I get 3 and 1 as the x values there. Again, I'm going to write it as a point. So 3, 0, and 1, 0 are my coordinates for my x-intercept. Now, admittedly, I have a problem here that I could factor. If it wasn't something that you could factor, you might have to use a quadratic formula. in which case you would need to write your final answer using the quadratic formula as two separate points. But either one of those ways you could potentially have to use in order to find those x-intercepts. The y-intercept, this one's a little bit easier, I think, because again, you're substituting 0 for the x value. So if we go to our equation, the y-intercept when you plug in 0 for x, you get 2 times 0 squared, which will be 0, minus 8 times 0, which will be 0, plus 6. So I get y equals 6 is that coordinate, or is that value. Now I do need to write it as a coordinate, 0, 6. And again, I'm only going to have one y-intercept, whereas I can have more than one x-intercept. But in this case, I always can only have one y-intercept.